Let's have one more video where we're going to be talking about how to reverse the order of integration in double integrals. I will show you two small examples, and I will just show you the example how to reverse the order, and then you can finish integrating. In this case, we have integral from 0 to 1, x to 1, e to the y squared, dy dx. This part doesn't really matter when we're switching the order of integration. So always keep an eye on what is going on with x and y. Since x is outside, so the x is standing outside, x is between fixed numbers. X is between 0 and 1. I will not even write it down, so that is actually a pretty important hint. But y is between functions, and this one I would write down. Y is between y equals x and y equals 1. So y is growing from x up until 1. That doesn't make sense until you sketch a picture. So let's do that. Actually, having a nice picture in these problems is crucial. X and y. So again, x is the easy case. In light blue, x is running from 0 to 1 as points. So values from 0 to 1. Then you draw these two functions I just wrote down. Draw or sketch, you don't need to be precise, y equals x and y equals 1. Just sketch them. Y equals x is some kind of line like so. Well, it's actually exactly y equals x, half of this first quadrant. Y equals 1 is the height, level 1. Here it is. How to understand that y is changing from x to 1. That means line is changing from the bottom up. It's growing up and it stops growing at 1. So it grows from line y equals 1 and stops at the level 1. No, it grows from line y equals x and stops at the level 1. While x is running on left to right situation from 0 to this point, which end up to be 1. It's over here. It's point of intersection over here. So y is growing up and down, rise, while x is growing from left to right, from 0 to 1, run. They want us to switch the order. This was originally type 2 or case 2. Originally it was type 2 when we had top minus bottom scenario. So the function top minus bottom is actually case 1. Yeah. Case 1 is when the x is outside, having fixed numbers. Then we have function on the top and function at the bottom, like so. X is fixed between numbers, y is growing between functions. They want us to change it into type 2. Type 2 will have fixed numbers for the y. Y will be running from fixed height to fixed height, while x will be between functions. And in this case, it's going to be from right to left. It's always the same idea. Larger minus smaller. It's just larger can be on the top or on the right. It used to be on the top, now larger will be on the right. Which function is larger? Y equals x is larger. So now the inside integral with respect to dx will have y equals x over here. But you have to be careful. X has to have name x equals blah blah blah. So you have to have extra step, solve for x. Luckily it's pretty easy. X equals y for the function on the right. X equals y. So now the scanning used to be from bottom to top. Now it's going to be from right to left, from right to left, from larger to smaller, right? So it's going to be from y equals x, from x equals y, till x equals what this line is. How to call this line, this left wall of the building. That is x equals 0. So it is going to be 0 at the bottom. X is changing from variables. 0 is growing from 0 to the line. That makes sense. You see, it's like so now. Y is fixed between numbers. What numbers? This height, which is 0, that is easy, to this height. To find this height, usually you need to find its point of intersection, but actually this height is given as y equals 1. The function inside stays the same, so we don't have to change that. And now we can write nicely that it is integral from 0 to 1, integral from 0 to y. What was the integral? E to the y squared, I think. dx dy, like so. Where, to conclude, let me finish saying that x is running between functions 0 and y. So it's a function x equals 0 and x equals y. That's the idea. While y is running between numbers 0 and 1. It's height. So now we have the idea that from left to right it runs between two functions, but from top to bottom it rises between numbers, like so. Let's do one more small and quick example where the order will be reversed the other way. Example 2. Example 2 is from 0 to 1. From 0 to 1. From 1 to the e to the y. Any kind of function inside, doesn't really matter which one, dx, dy. Okay, if y is outside, then y is fixed between numbers this time. But I would start with x. X is fixed between functions x equals 1 and x equals e to the y. Write this down. X equals 1. X equals e to the y. X is running between these two. Graph these two functions. X equals 1 is easy. That is just a vertical wall. X equals 1. E to the y, that's the exponential function. You can draw it like so. X equals e to the y. And it's actually the other way around. It starts at 1 when y is 0, e to the 0 is 1, and it's going like so. Either use a graphing calculator or you should see its inverse function here. So exponential function is like this, but it is y equals e to the x. X equals e to the y is, you see, concave down looking shape like so. Anyway, this is the idea. This is 1, they meet here, and then there is a line at the top that cuts everything off, but we'll figure this out later. So the idea is that x is running between these two, between 1 and e to the y. X is running from left to right. You have to keep imagining this. The smallest value of x is this line, and it's keep increasing like so. So the integral was top minus bottom, which is right minus left. That is type 1. We need to change to type 2. Type 2 means now I want to do... I keep mixing up the types. This is so annoying. From right to left, it was type 2. From right to left. Yeah. Now we need to have type 1. To have type, I keep mixing types because in my mind I actually don't really care the name of the type. I see it one way and I need to do it, there's only one more way to do it. It used to be on axis changing from function to function. Now we want to have from the y-axis, running from function to function instead of number to number. Well, what function is greater? The one that's on the top. That is the function x equals e to the y. We need to rewrite it in terms of y. What function is at the bottom? The function is at the bottom is the function is at the bottom is x equals e to the y, and we need to write down as y equals blah blah blah. Yeah. What is the function at the top? That's some kind of vertical line, so we need to figure out what height is that. That is the idea. Okay, to figure out that, let's write down x equals e to the y is going to be at the bottom. We're going to solve for y. That's going to be ln x. We know that. So this is going to be the bottom of the integral. You can start filling in if you want. It's going to be ln x at the bottom, and the y goes first. So it should be like y equals blah, blah, blah. What is the function at the top? To find the function at the top, you need to figure out this intersection point, or this intersection point, and any information you have. But we actually never use this information. Y was fixed from 0 to 1. So this is the function which we can call y equals 1. So we don't even have to solve for it. It's already there. And you can check that it is matching. When y is 1, it intersects with this x equals e to the 1. So it makes sense. Now, it's going to be till the ceiling. And the ceiling is y equals 1. So to the 1. We are done with dy. And the x now will have numbers instead. Whoever is standing outside should have numbers, or else the volume will not have a finite number. X is running from this point to this point. The first point is obviously 1, and the second point is the point of intersection. Let's call it P. P is the point of intersection of y equals 1 and y equals ln x. That's actually... Okay, we can do that. It's fine. And then we can solve this. I would use e to the y, to be honest, but it's fine. So, to solve this, you have 1 equals ln x. Well, when ln of what gives you 1? X is e. So the second number, e, is like 2.7. It's going to be e. To rewrite it nicely, we usually don't write y equals, so it's going to be from ln x to 1, a function dy dx. And this is how you reverse the order of integration. So again, functions inside, this is the function, and this is the function. Fixed numbers outside in order to get a finite number of the volume as the number, not a function. Number should be outside. All of this usually comes from the image, so you need to be good at sketching the image. Don't be bothered between regulating type 1 versus type 2. It's always one way versus another way, so if we did it using left function x equals 1, which was here, and function on the right, which was x equals e to the y, and now we need to switch from top to bottom. We rewrite everything in terms of another variable. In this case it's y, and we wrote it. It was x equals e to the y. Now it is e ln x. The top function was never named, and we figured the height is 1, so it's y equals 1. So these two were used to reverse the order, and then you figure out how x is running here on the x-axis from which number to which number, from 1 to this point of intersection P. And you found this P usually from equations, like so. Hopefully it helps you to do better these problems whenever you see them. Thank you for watching.